Hello viewers, in today's class we are going to solve one important definite integral, right? So here we have this integral that is from 0 to pi by 2 x sine x cos x divided by cos raised to 4x plus sine 4x, right? Okay, so now let us start. So let us first call this integral as I, right? So let us take this integral as integral number 1. Now here uh, in order to evaluate this integral we have to make use of one important property of definite integrals, which says that if we have the integral from 0 to a f of x dx, then this x can be replaced in the next step by a minus x, right? So this property shall be used here, right? So here we see that a is pi by 2, and therefore a minus x is equal to pi by 2 minus x, right? So now what we will do in the next step, right, the step immediately after this, will replace uh, all x, right? Here all x will be replaced by pi by 2 minus x, right? So this integral now takes the form 0 to pi by 2. Here we have pi by 2 minus x, we have sine pi by 2 minus x cos pi by 2 minus x divided by cos raised to 4 pi by 2 minus x plus sine raised to 4 pi by 2 minus x, right? So what we have done here, we have replaced each x by pi by 2 minus x due to this property, right? Now here we'll make use of two important results, that is sine pi by 2 minus theta is equal to cos theta, and cos pi by 2 minus theta is equal to sine theta, right? So now this integral, it takes the form 0 to pi by 2. Here we have pi by 2 minus x, this becomes cos x, and this becomes sine x dx, and cos is changed to sine, so here we have sine raised to 4x plus cos raised to 4x, right? So now this integral can be written as a sum of two integrals by writing 0 to pi by 2. First we will take see, here we can write this integral as 0 to pi by 2 times sine x cos x dx, right? So we can also write it like this. So here we have minus x sine x cos x, and then we can write dx, right? And divided by sine raised to 4x plus cos raised to 4x, right? By we can multiply these two terms by this term cos x sin x, right? Now from this point we can split this integral as a sum of two integrals. So now we can write pi by 2 sin x cos x dx over sine raised to 4x plus cos raised to 4x minus 0 to pi by 2. Then we have x sine x cos x divided by sine 4x plus cos raised to 4x dx, right? Now we see that here this integral is same as the original integral, right? So this whole integral can be replaced by I here, and this becomes minus I, and if we take minus I to this side, we get I plus I, that is 2I, right? And we can write this integral 0 to pi by 2, and this pi by 2 can be taken outside, and we have sine x cos x dx over sine raised to 4x plus cos raised to 4x. Now this 2 can be taken here, so now finally we have I is equal to pi by 4 and 0 to pi by 2. Then we have sine x cos x dx over sine raised to 4x plus cos raised to 4x, right? Now we have to solve this integral, and what we will do, we'll divide the numerator and the denominator by cos raised to 4x, right? So let us do. So now if we divide this numerator and denominator by cos raised to 4x, we'll get integral pi by 4 here, then 0 to pi by 2, and we have sine x cos x divided by cos raised to 4x dx divided by sine raised to 4x divided by cos raised to 4x plus cos raised to 4x divided by cos raised to 4x, right? Now we can simplify it. This is a simple step here, because see here cos x and 1 cos x get cancelled. See, we have cos x and cos raised to 4x, so cos x and 1 cos x get cancelled, so we are left with cos cube x. Cos cube x can be written as 1 over cos x times 1 over cos square x, right? So here we have now sine x over cos x times 1 over cos square x dx, right? And in the denominator we have sine raised to 4x over cos raised to 4x is tan raised to 4x, right? Okay. So now here cos raised to 4x and cos raised to 4x get cancelled. So now we have 1 plus tan raised to 4x, right? So now here we have pi by 4, and then integral from 0 to pi by 2, and sine x over cos x can be written as tan x, and 1 over cos square x is equal to sec square x, and here we have dx divided by 1 plus tan raised to 4x, right? Okay, so now at this point we can use the method of substitution. So viewers, now let us substitute here y is equal to tan square x, right? So here we are making use of substitution method, and let us substitute y is equal to tan square x. So therefore dy over dx is now equal to 2 tan x, and by chain rule the derivative of tan x is sec square x, right? So now this can be written as dy over 2 is equal to tan x sec square x, right? So for tan x sec square x dx we can substitute dy over 2, right? Now since we are changing the variable from x to y, so let us change the limits accordingly. So when x is equal to 0, then y is equal to tan square 0, that is 0 square, that is 0. And when x is equal to pi by 2, then y is tan square pi by 2, and tan pi by 2 is infinity, and infinity square is infinity, so here we have infinity, right? So therefore now I can be written as pi over 4, and the limits are from 0 to infinity, and for this term we have dy over 2, and for this term we have 1 plus y square, right? Because this is 10 raised to 4, so if we square both sides we get y square is equal to 10 raised to 4x, right? Okay, so now we have this integral. This can be written as pi over 8. Taking this 2 outside the integral, we have 0 to infinity dy over 1 plus y square, and this is a standard result that 1 over 1 plus x square is equal to tan inverse x. So here we have pi over 8, and we have tan inverse y as the definite integral of 1 over 1 plus y square, and the limits are from 0 to infinity. So we have pi over 8 tan inverse infinity. We'll substitute the upper limit and lower limit, and we'll take the difference, and here we have tan inverse 0, right? So now this is pi over 8, and tan inverse infinity is pi over 2. Tan inverse 0 is 0. We know that tan pi by 2 is infinity, so pi by 2 is equal to tan inverse infinity, right? So now tan inverse 0 is 0, so now we have pi over 8 times pi over 2, so now this is pi square over 16, right? So viewers, the value of this definite integral is pi square over 16.